Hey, I'm Mac,
I'm Abraham.
I'm Max.
and this is the halfway check-in point for our TARS Interstellar project. Early June, we decided that we wanted to make the robot from Interstellar, the blocky guy. So this video is going to go over the different aspects of the robot, what we've accomplished so far, what we're currently working on, and what we plan to do in the future. So hopefully we will give a good overview in this video and give more details later. So good inspiration for this project was online. We've seen a lot of people making small scale like mini TARSs that have like some sort of like chat GBT. They can like recognize things and then uses it to like walk around and stuff like that. So I don't know, maybe you've seen those videos, but that was like a good starting point to like sort of try and replicate that before we went into actually making like the big life-size guy. So in front of us here, there is our sort of replicant of that. In Interstellar, TARS has many ways he can walk, and generally he can change his pivot point to be at his middle or at the top. And then also he can like spin around and stuff. But we decided that for this project it'd be easiest for us to just have the pivot point be in the middle, even though we've seen a lot of videos of people having their pivot points at the top instead. And then also we decided that it would be very important to have some sort of like shoulder component where you could lift up and down the pivot, and that would make it easier to walk. So with this guy, what we did is we took these like brushless drone motors and these like small linear actuators that we found on Amazon, and we used it to basically make this arm joint here and here. And this moves up a little bit and down a little bit, and it's very marginal, but for this project it gets the job done. Then for the big guy, we obviously had to make it a lot more powerful because this is going to be like 6 foot tall and made of like aluminum extrusion, like structure, frame, stuff like that. And I mean the batteries alone are 50 pounds, so it's like we had to make it a lot more powerful. And we searched for a bunch of different motors, and we found these like robot dog motors, R100s. And then instead of a linear actuator, we decided to do a rack and pinion. So we had like a motor with like a pinion on it, and it like drives a rack and it goes up and down. And then we have these two linear slides that help guide the movement up and down of the carriage that the like pivot arm is on. And then we realized we would need a lot of torque out of the motors, so we also designed a cycloidal gearbox to get us a 1 to I believe 132 gear ratio, which would significantly increase our torque while also giving us a good amount of movement speed out of the joint. And then put that all together, and that's the mechanical aspect of the big guy.
So I will be talking about some electrical stuff and also some of the simulation software that I've been working on. So for the electrical, we're using brushless DC motors because that's very similar to what we're going to be using on the larger version. So in here we have some smaller drone motors that we're using to drive the pivots on all of these sections. And on the big version, we're going to have these 250 Newton meter motors that move the entire like 6 foot aluminum section along. So they have to be pretty powerful, and they're reduced by the cycloidal gearbox that Mac was talking about earlier. For the wiring, we just use some perf board to wire together the ESP32s, the main control board to the CAN transceivers and all of the CAN stuff. And it's a little bit messy, but it works. For the simulation that I've been working on, just kind of simulates the walking pattern that both the small one and the large one will use. So basically lifting up the shoulders first and then swinging the two outside sections forwards, and then like kind of like ape walking or like walking with crutches, using that kind of pattern to walk along. We're also hoping to get like the full spinning going on as well. So I'm working on the simulation for that, for the small one and the big one. For the walking simulation, we needed to do that because we wanted to figure out how exactly this thing was gonna move its like limbs around and walk, so that we knew how it was gonna look when it walked, and like which order to send the commands in to the motors and have it move in the right way.
Brushless motors aren't really as simple to drive as normal DC motors, so we needed pretty expensive brushless drivers. But thankfully, STM Electronics makes some really cheap brushless motor drivers So we use those. Those give us some really powerful position control over each of our motors. And then we bought some pretty cheap Amazon drivers for the DC motors and linear actuators. For software, we just put simple FOC in our brushless drivers and then use ESP's provided libraries to code the EC32 mainboard, which gives us pretty easy control over all of our motors over CAN. For the small version, we decided to go with CAN because pretty much every large robotic actuator uses CAN to communicate for position control. So CAN is pretty challenging. The ESP32 has a built-in CAN module, but we needed to buy external CAN transceivers. But our STM board has a built-in CAN transceiver, so it's pretty easy to communicate. But we spent a while just trying to get the CAN bus to work because CAN is kind of hard to get started on. But once that was done, it was pretty easy to send communication back and forth between both nodes.
So for the next month, we are going to be working on getting this little guy up and running, moving, maybe get like a ChatGPT like voice and like stuff on it. And then we're going to be building and hopefully getting the big guy working. So end goal is have this 6-footer actually walking around at like a decent pace. And if we have extra time, maybe start looking into doing some like the extra arm movements and maybe even the big rolling like running thing. So we'll see.